Hello, my name is Alan Ignatin, the Chief Technology Officer of BitSpeed. I'm going to demonstrate two significant features of our new product, BitSpeed Velocity. Velocity is a program that optimizes and accelerates LAN, WAN, and satellite connections, allowing full utilization of available bandwidth regardless of latency. Velocity is implemented entirely in software, is available for all major platforms, and requires no changes to your operating environment or system kernel. For most of us, there's a need to transmit data from one system to another, either across the room or across continents and oceans. For small files, or even groups of small files, the normal tools of your operating system, such as FTP, SCP, rsync, and others, are probably sufficient to get the job done in a reasonable manner. Not at top speed, mind you, but fast enough for infrequent or low data volume use. But if you've got lots of data in large files, and here I'm speaking of gigabytes or even terabytes of data, the standard tools you've been using can leave a great deal to be desired. The methods of transferring files you've been using are, simply put, not very efficient. Most importantly, none of the popular tools makes full use of the available bandwidth. In fact, it's not unusual for these programs to use only about 40% of the bandwidth you have. Now, over a local area network where latency is usually below 1 millisecond, that's not too much of a problem, although there's much room for improvement on LANs. But if your data is traveling over a wide area network or WAN, perhaps from Los Angeles to New York, latency is about 80 milliseconds. From Los Angeles to London, latency is about 140 milliseconds. As the distance between the source and destination increases, latency takes an increasing toll on throughput. As latency increases, performance decreases. On your local area network, you're probably using gigabit Ethernet. That means you can transfer 1 billion bits over the line at the same time, the equivalent of a theoretical maximum of 125 megabytes per second. Layer on a bit of computer overhead like operating system process management and reading and writing to and from disk, and you're down to about 118 megabytes per second. Not bad, right? Well, not really achievable either. For all the reasons we've just discussed, it's pretty rare to get to that performance level, unless, of course, you're using BitSpeed Velocity. Now, let's do a live demonstration of moving data over a local area network where the latency or round-trip time is less than 1 millisecond. I've logged onto a server on my network, and I'm going to first use SCP to transfer a file of about 1 gigabyte to another server on my network. Remember, the latency on this network is less than 1 millisecond, but also please remember what I mentioned earlier about program inefficiencies, even on local area networks. So, here we go. SCP reports completing the file transfer in 17 seconds at a transfer rate of 56.4 megabytes per second. Now, let's perform the same file transfer using the popular rsync utility. rsync reports completing the transfer in 19 seconds, running at 49.9 megabytes per second. Now, let's use BitSpeed Velocity to transfer that same file over the same network. Velocity completed the transfer in just over 8 seconds, running at 118 megabytes per second. Now, using the compression option of Velocity, let's try that same file transfer one more time. Velocity with compression completed the file transfer in 3.6 seconds, at a data transfer rate of 285 megabytes per second. In the interest of time, I've run some tests using SCP, rsync, and velocity to transfer a different file of 1.8 gigabytes over a 1 gigabit bandwidth from Los Angeles to New York. Here's a screenshot of those tests. I've highlighted the important data in yellow for easy identification. First, I did a trace route to verify the latency, in this case, just slightly over 80 milliseconds. On these tests, SCP and rsync performance was almost identical, running at about 12 megabytes per second and taking over 2.5 minutes to complete. Velocity, over the same connection and latency, completed the transfer of the same file in just 18 seconds, running at 114 megabytes per second. Then, using the compression option of velocity, the same file transfer completed in just 11 seconds, running at 196 megabytes per second. Another set of tests were run using the same file and transfer utilities on a Los Angeles to London connection with 140 milliseconds of latency. On these tests, SCP and rsync both took about 4.5 minutes to complete, running at just under 7 megabytes per second. Velocity, over the same connection and latency, completed the transfer of that same file in less than 20 seconds, running at 111 megabytes per second. Then, using the compression option of velocity, that same file transfer completed in just 13 seconds, running at 188 megabytes per second. These results are summarized on this chart. As you can see, velocity completed the test is at between 9.4 and 27.3 times the speed of the common file transfer utilities. BitSpeed velocity, full bandwidth, worldwide. Thanks for joining me. Please give us a call, visit our website at www.bitspeed.com, or write to us at info@bitspeed.com.